Question 11. A dart player stands 2 meters from a dartboard and she throws the dart horizontally, so no J, with speed U, from a height of 1.6 above the ground, and it strikes the board at 1.5 above the ground. Okay, what have we got here? Let's do a little diagram. So she's thrown the dart horizontally and it's coming down to here. So it's starting at 1.6, coming down to 1.5, across here, and here's the board, 1.5 above the ground. So it hits the board at this point, and it's 2 meters away. So we have S of x is equal to 2. S of x is also equal to ut. We're told it's just u. So we need this time here. Now my initial velocity vector is going to be u times I plus 0j here, because there's no displacement, or there's no, it's just horizontal, so there's no vertical position for j. So if we look at our S of y, displacement of y is minus 0.1, the difference between 1.6 and 1.5. So my ut plus a half at squared is equal to this minus 0.1. This is 0. So minus 4.9t squared is equal to minus 0.1. So 49t squared is equal to 1. So t squared would have to be 1 over 49, giving t a value of 1 over 7. Could be minus 1 over 7, but not for time. So 1 over 7 seconds is the time. We're also asked the initial speed of the dart. So we can say here that S of x is equal to ut, which is equal to 2. 1 over 7 times t is equal to 2. No, 1 over 7 times u is equal to 2. T is the 1 over 7, so u is equal to 14. And we're asked for the speed of the dart that hits the board. So we need the velocity of x, which is going to just be 14, and the velocity of y, u plus at. The velocity of y is 0 minus 9.8 times 1 over 7, which is going to be minus 1.4. So my final vector is 14i minus 1.4j, and the speed of it, the magnitude of this velocity, is the square root of 14 squared plus 1.40 squared. That works out to be 14.07 meters a second. So short enough question 12, and that's it for question 12 or question 11. On to number 12. So question 12 has a repetition question here, showing that the range is this. So you guys probably have practiced this 33 times at this point. So let's just do it real quick again. We want the range. Here's the position O. So at this point, S of y is equal to 0. We're looking for S of x, so we need the time taken to get there. So S of y is equal to, well, I think let's write down our initial vector. It's equal to u cos alpha times I plus u sine alpha times j. So I'm displacing my ut plus a half at squared, where a is equal to minus g, is going to give me u sine alpha times t minus g over 2 times t squared. So factoring out my t, I get u sine alpha is equal to 0, u sine alpha times t minus gt over 2. So my initial time is equal to 0, and my u sine alpha times t, leaving out my alphas, is equal to gt over 2. 2u sine alpha times t over g. No t in here. I put in t instead of an 8 u sine alpha, Going too fast. U sine alpha 2u sine alpha over g is equal to t. So now we put this into s of x, displacement of x with no acceleration is equal to ut. So u cos alpha by 2u sine alpha over g, which is equal to 2u squared sine alpha cos alpha over g. So obviously you need to practice that a lot and not make mistakes. So what are we told now? The particle passes through 2 points whose displacement from O are 3i plus j and I plus 3j. Show that the range is 13 over 4 meters and tan A is equal to 13 over 3. Okay, we'll leave them visible. We'll do it over this way. I've got my points, I've got my range, and I've got my tan A. So there's a bit involved in this. We have 3i plus j. So we can say that s of x, displacement in x, is equal to 3. And the displacement in y is equal to 1. So what we can do is we can get t in terms of u for my s of x. S of x is equal to ut. So we can say that we don't know u and a, so u cos alpha plus u sine alpha. So s of x is equal to u cos alpha times t at any point, and that's going to be equal to 3. So the time taken is going to be 3 divided by u cos alpha. So the only other information we have is displacement in y. So displacement in y is equal to 1 when s of x is equal to 3, and we have the time here, so we can sub that into ut plus a half at squared. I think we get something in terms of u squared here that we have to then replace in the second equation. So this question is quite long. So displacement in y is going to be u sine alpha by t, which is 3 over u cos alpha. Then we're going to have minus 4.9. The g, I think we could leave the g's out here. 4.9 by t squared, which is going to be 9 over u squared cos squared alpha. And that's going to be equal to 1. So my u's cancel, and I'm left with 3 sine alpha over cos alpha, which is 3 tan alpha, minus 9 5s are 45, 44.1 over u squared cos alpha minus 1 equals 0. So I may as well bring that u squared, the 1 over cos alpha is equal to tan alpha, 1 minus tan squared alpha. So the cos square part left it out. Just be careful not to leave these squares out. So 3 tan alpha minus 44.1 over u squared by 1 plus tan squared alpha. So that we have 2 unknowns here. We're going to need 2 equations, so that's where the second point will come in. And that's minus 1 equals 0. So 3 tan alpha minus 44.1 minus 44 tan 0.1 tan squared alpha and both of those are over u squared. We're going to simplify for u squared here because we can get u squared in both equations now and let them equate, and then minus 1 equals 0. So 1 minus 3 tan alpha, we bring them both to, actually we could leave it as 3 tan alpha minus 1. We leave them on the left. 3 tan alpha minus 1 is going to be equal to, well, this is like having a minus 1 in front here of this, so it's going to change signs when we bring it across. So it's going to be 44.1 plus 44.1 tan squared alpha over u squared. So if we solve this in terms of u squared is equal to, I think this will help us get to the answer. So we're going to have 44.1 plus 44.1 tan squared alpha. Now we could factor out 44.1, but I'll leave it like this for now, over 3 tan A minus 1. So if we can get the second equation written in this form, we'll be able to let them equal each other. And then we should be able to just have tan alpha as the unknown, or tan A as the unknown, and we should be able to get A. So let's do that. We have, second point is I plus 3j. Okay, let's look at I plus 3j. So s of x is equal to 1 when s of y is equal to 3. So u cos alpha s of x times t equals 1. The time at that point is 1 over u cos a. And we substitute this into s of y being equal to 3. ut minus 4.9 t squared equal to 3. We're going to get u sine alpha times time, which is 1 over u cos alpha, minus 4.9 by t squared, which is 1 over u squared cos squared alpha, or 1 squared to see the 1 on top, and then minus 3 equals 0. So we've got my u's cancelling, leaving me with sine alpha over cos alpha, which is tan alpha, minus 4.9 over u squared. Now I'll do the one, we know it's over u squared times 1 plus tan squared alpha, that 1 over cos squared alpha, minus 3 equals 0. So tan alpha minus 3 is equal to 4.9 plus 4.9 tan squared alpha over u squared. So in this case it's the same vector, same projectile, so u squared is equal to 4.9 plus 4.9 tan squared alpha over tan A minus 3. Now, I'm actually going to turn them back into, we can let these u squareds equal each other, but I'm going to turn those decimals back into g, in terms of g, because I think it works out better. So let's have a look here. 44.1 is 9g. Well, what was it up here? We should have left it as, say this, this would have been g over 2 times 9. So 9g over 2 is this 44.1. So 9g over 2. And we could factor out the 1 plus tan squared a on top. And that's over 3 tan a minus 1. That's equal to this guy here, which is g over 2, not 4.9, g over 2 by 1 plus tan squared a on top, and tan a minus 3 on the bottom. Now we could divide by 1 plus tan squared a, but I'll write it out in long form. 9g over 2 by 1 plus tan squared a. We're cross multiplying here, by tan a minus 3 equals g over 2 by 1 plus tan squared a. And you can see they're all multiplied here, so we can divide by 1 plus tan squared a by 3 tan a minus 1. Bit long-winded, so we can divide by 1 plus tan squared a. We can multiply by 2. We can divide by g, and that leaves on the left 9 by tan a minus 3. So 9 tan a minus 27 equals, well, on the left we just have, on the right, 3 tan a minus 1. We're getting close here. So 9 tan a minus 3 tan a, 6 tan a equals 27 minus 1, which is 26. So tan a is equal to 26 over 6, which is 13 over 3. Hopefully that's what they wanted. All the way back. Oh, brilliant. Tan a is 13 over 3. Okay. And then we're asked, show that the range is 13 over 4, and that tan A is 13 over 3. Okay, so we need the range now. We need the range. The range, what do we have for range here? Range is equal to 2u squared. Is this what we were asked in part 1 of this? To show this sine alpha cos alpha over g. So we need 2u squared, we need sine alpha, and we need cos alpha. So alpha opposite 13 over 3 over adjacent. So the square root of 169 plus 9 is 178. So cos A is equal to 3 over 178 square root, and sine A is equal to 13 over the square root of 178. So 2u squared, I think we had u squared up here, didn't we? We had u squared. Which one will I use? We had u squared is equal to, doesn't really matter which one I use. This one here, 9g over 2. That's u squared. So if I double it, I can get 2u squared. Okay, so if I double it, I'm just gonna 2u squared. So this is u squared. So 2u squared. If I put a 2 on, if I multiply the top by 2, it's just going to cancel with the 2 on the bottom. So we're left with that 9g by 1 plus tan squared a. 2u squared is equal to 9g by 1 plus tan squared a over 3 tan a minus 1. 3 tan a minus 1. Okay, let's fill these values in. We've got 9g times 1 plus tan squared a is, that's tan a, tan squared a, 169 over 9. Divided by 3 times the tan of a, 3 by 13 over 3 is 39 over 3. Minus 1. They can get a little bit long-winded, these questions, so I've got to multiply this by sine a cos a, which is 13 over root 178 times 3 over root 178, and then I got to divide by g. Now I'm going to turn g into 9.8 here in the calculator, or we can divide top and bottom by g and they'll cancel, won't they? So either way, so we could multiply these guys out. I think just type this into your calculator, and you may need a few attempts, but it does come out at 13 over 4 meters. So that's an extremely long-winded question 12. Let's look at question 13. I'll put that in the next video, 13 and 14 together.